Long division with partial quotients. Let's do it. Solve long division problems by using partial quotient. Example problem. 345 divided by 7. The first thing you want to do is set it up. Instead of drawing the regular long division symbol, you're going to draw the same thing, but make the end a little bit longer. Almost like a big number 7. Now look at your divisor. In this problem, your divisor is 7. We're going to be counting by sevens. We're going to make a T-chart, which, yeah, you guessed it. It's a letter T. And we're going to count by sevens. On one side, count to 9. And on the other side, count by sevens. Now we're going to look at the dividend. The dividend is 345. And we're going to count by sevens until we get close to 345. You can see when we get down to 9 groups of 7, it's 63. So we just gotta keep counting. 5 years later. So yeah, nobody wants to count by sevens all the way to 345. So there is a trick. We can multiply each of these by 10. And we're going to get really close to 345 really quick. So let's add zeros on both sides. Now that we have bigger numbers, we're going to look down the row and try to get as close to 345 as we can. As I'm looking down, I see 350. That's really close. However, we only have 345. So 350 is too big. So right above 350 is 280. It's not as close as I would like, but that's the closest we're going to get. I like to think that 280 and 40 are married. They go together. So if you use the 280, you must use the 40. So let's use 280 and 40. 40 becomes part of our quotient, which is the answer, and 280 is what we're going to subtract. Now you subtract. Don't forget to regroup. That is the number one problem with long division. If you do not regroup, you will get the answer wrong. So yeah, regroup please. Whew, you made it this far. Great job. Now, guess what? You have to repeat all of those steps again. You got this. Let's keep going. Now, instead of 345, we're working with 65. So, when we have our zeros here, the first number on the subtraction side is 70, which is, yep, it's too big. So we need to we gotta get rid of these zeros now. We don't need them anymore. All right, let's look down our list. We're trying to get close to 65. Looking down the subtraction side, the closest I can get is 63. Now remember, 63 is married to 9. If we use 63, we have to use 9. All right, we subtract, and we have to figure out if we have a remainder. 65 minus 63, well, that's 2. 2 does become a remainder because 2 is less than 7. Once you get to a number that is less to your divisor, you know you're done, and you'll know if you have a remainder. It's been a long journey, but we're at the end of this problem, and you can see that my quotient is 49, remainder 2. In the number 345, there are 49 groups of 7, and there would be 2 left over. Yay, we did it! So, thanks for watching. If you don't like partial quotients and you like the standard algorithm, there will be a video for that. If you don't like either of those, there will be a video for area models. You gotta pick a way that works for you. Yeah. Like and subscribe.